So in this class, we are gonna get to have an understanding of of how to derive a standard equation for R like that with conic sections. So we're starting with question 13. So what they're asking us is drive a standard equation of the form. So they've given us this is like it should be of this form here for a conic with one of the focus. So they tell us one of the focus is at the origin and its associated directrix. So the directrix now of that conic section, which is at the origin, which has focus at the origin, then they're telling us that we have one, like in A, that it's vertical and it's P units to the right of the origin, horizontal P units to the above, and horizontal P units to the below of the origin. So these are, you have to find for those points there. But now to come to the establishment, first of all, we have to understand. So if R is the general form and it's given by EP over what? 1 minus E cos what? Cos theta. Cos theta, like this. So now, what are we gonna, or what do we get to understand from here? So what we get to understand from what we've been given in the question is that, first of all, the focus of this, one of the focus is what? Is at the what? At the origin. So we know that this can give us different conic section. It can be a case of an ellipse. An ellipse has foci because it's what? It's two. Then we have what do we have? We have hyperbola also has two. You have hyperbola. You have what is a parabola having one, and which other one? Okay, though we don't consider the second in this case, mostly we consider this three. So the hyperbola and ellipse have two. They have a foci. They have two focus. So it's a foci. Then the parabola has a what? A focus. So now they're telling you that one of them is what is at the origin. So one is at the what? At the origin, and that origin we know it is what? It is zero, or to mean what? To mean origin. Then the directrix here. So remember, I'm talking of the general form now. The directrix is always, like this is the directrix is the distance from what? From the origin, and this distance is given by what? By P. So this is just a distance from what? From O, from the origin to where the point what? The point P is. So this is just a distance from the origin to the point what? P. So we're naming it what? P, like this. Since if it goes from zero, if you are in a graph like this, I move from the origin going to a point, let's say this point here, and this point is P. So it's a distance, it's P units from the what? From the origin. So that's the thing that we established there. Then we were saying that the standards, now these standards, just the same way, this here, they've just given us this one, but this is not the only one, which is there. So now we're going to say that the standards for the conic section in polar coordinates, since we're dealing with polar coordinates, I forgot to mention that this is a question on polar coordinates. You have that the directrix. So you have the directrix. So you have a case where the directrix is what? To the right of the what? Of the pole. So the pole, that is, we're saying the pole, the origin, that's where it's what? It's starting. So now you're saying your directrix is to the what? To the right of what? Of the pole. So directrix to the right of the what? Of the pole. Right of the pole. So now, when you're dealing with the XY plane like this, and you're saying, if this is your origin here, to the right means what? It's here. That's where that's where your your directrix is, to the right. Then where it cuts now, so you see here when it cuts, it's gonna be a vertical line. So this will be at what? At P. So from one focus, that there the directrix, and that would be what? That would be at P. So this here, we're saying it's a directrix that is what? That is to the right of what? Of the pole. And such here, such in the polar coordinates is given as R to be EP over, and we're saying this will be just, so since it's to the right, so you have one, the sign here will be what? To be positive, showing that it's what? It's to the right. Then you have E cos what? Cos theta. Then I know from there you would have guessed it right that the standard one, or the one which they gave us in the question, where you have EP over 1 minus E cos theta, this one is going to be what? Is going to be to the left of what? Of the pole. So this one is going to be to the left of the pole. Then now we have the other cases where you have it above the pole. So you have it above the pole. So you're going to have this case here where it is above, let's say it's above there. So because it's above, it's going in the positive what? Y region. Yeah, in the positive, yeah, it's cutting in the positive Y axis. So this here is gonna be R equal to what? EP over, then that is gonna be what? That is gonna be 1 plus E sine what? Sine theta. So now when it comes to dealing with the Y axis, we now move on to what? To use sine. So remember, even when you're dealing with vectors and all, in the y you use sine, in the x you use cos. So now because we're in the y, we're gonna use sine. So you have that one there. Then yeah, I'm sure you guessed it right from here to say if it's down like this here, down the pole or below the pole, then you just have R is gonna be what? EP. Then you have 1, because it's down, it's gonna be minus since it's in the negative region. E, then you have sine what? Sine theta. So these are kind of the standards now that you have. So now from here, what they're just telling you, in fact, this derivation here, there's not much of even any derivation going on, but you're just gonna write that equation depending on what statement they've kind of given you from these that we just from listing down and from uh, learning of. So now the one that they're telling you, number one, so they're telling you it's vertical. So that let me read the question again. So it's saying drive a standard form of an equation R, this EP. Okay, we know the standard form for a conic with one focus at the origin. So the focus at the origin and its associated directrix. So now the directrix is what they are describing, saying it's vertical and its p units to the what? To the right. If it's vertical, what does that mean? It means that that directrix is actually cutting the what? The x-axis. So if I have my like this, it's vertical and it's to the right of the what? Of the origin. So if that's the origin, to the right, meaning I'm moving this side, and it's vertical, so it's gonna cut like that. So now if it's gonna cut like that, I know from what I've written that this here is just gonna be R E P, then over what? So you have 1 plus. Now you have plus because it's to the what? To the right there. And you have E cos what? Cos theta. So that's going to be for the first one. The one that follows, they're telling you it's what? Horizontal. And it is what? It is P units above. So horizontal, P units above. From the origin here, P units above, it's going to be there. So this now, and since it's horizontal, meaning we're going to switch now to what? From cos towards to sine. And you have 1 plus E sine theta. So this is what you're going to get. Then the last one is horizontal, P units below there. And this is just going to be R equal to EP divided by 1 minus E sine what? Sine theta, like that. So this is what you get. Okay. Unless there are any questions here, but I want to make a move and just go on to the next one. If there's any, feel free to ask. Okay, so now having established that, then we can tackle these questions here, because it wouldn't have made sense if we start tackling that without getting to understand the standard form of what of the equations and what they mean. So in the first case, so now okay, maybe something that we didn't mention is you have R, you have E, P, then you have, let's say, 1 E sine cos theta. So this is the angle. This is just an angle we're dealing with. Then E, the E you see here is your what? Your eccentricity. The E is the eccentricity. Then you're saying that this P here, the P is what? Is the distance from the origin to the what? To the directrix. That is gonna be your what? That is gonna be your your P there. Okay. So now the question here, the problem is in problem 9 through 12, they're saying identify the particular conic section and give its eccentricity and the distance of the directrix from the origin. So they're saying the right-handed directrix if the curve is what is a hyperbola, left-handed if the what the curve is an ellipse. Yeah, so that's what they're telling you. But what's important, you're saying here to get out of this is that you have to identify the particular equation. Okay, after identifying what give its eccentricity, then also find the distance of what of the directrix from what from the origin. So this is what we're getting from here. So now let's kind of work that out with the first one. Let's start with the first one. So with the first one, you're gonna have that you have r is equal to 7, then you have 1 minus sine what sine theta. So now from here, what you want to identify is what is my E. So your E, okay, maybe something else that I did not mention here is so your eccentricity, when your eccentricity is equal to 1, so when E is 1, we're gonna get a parabola. It's gonna get a parabola. Then when E is greater than 1, this gives us a hyperbola. Then when E is actually in between, so in between uh, 0 and 1. So when your eccentricity E is in between 0 and what and 1, this gives you an ellipse. So this is what you get. Now so having that now information, we can now easily identify what these conic sections are, and we can find exactly what we are being told or what we are looking for in those questions. So let's start with this one. So we said R already to be equal to that. So now with here, I have sine, but what is in front of sine? I have a 1 that is in front of sine. And remember, I said in front of sine from the general form, which is going to be R equal to EP divided by 1, then minus E sine what? Sine theta. So in our case, our E is actually what? This E is actually 1. So if it's 1, meaning my eccentricity is going to be equal to 1. So eccentricity is equal to 1. Then what is this here on top? Here on top is the EP. So EP is gonna be equal to what? To 7. So if EP is equal to 7, then which means I can find my P value. So my P value, if I replace here 1 where E is, so I replace 1 there and 7, and I just get that my P is just going to be equal to 7. So that's going to be my P. Now, so we're saying to answer the question now, we found this, but now does that really answer the question and what we are looking for? No, we have to state that. So we say since our E is equal to what? To 1, we have our E equal to 1. This means that our conic section, is just gonna be a parabola. So it's gonna be what? A parabola. So you state that it's gonna be a parabola. Then the distance of what? So eccentricity. I've already said it. Eccentricity is equal to E, and we've calculated that. So we've answered that part as well. We've identified now the distance is what we need of the directrix from the origin. And of course we've calculated that to be what, to be p. So we're saying the distance from of the from the origin of the directrix is just so I can just say distance of directrix. I guess you understand that our starting point is the origin, is just p equal to what, to 7. And this here, what you would have then identified whatever they're asking for in that question. Okay, so this is how you do that, unless there's any question on this. But I want to move ahead and just do, okay, the rest are not in standard, so it's gonna be good. We have to first put them into standard. Since they're 4 on this one, we just okay, let's just do all of them since they're just 4 questions here. Yeah. So now keep all this here, all this in mind what we're from doing. So we have, let's do 10. 10x, it says, all right, it's 5. 1 plus 3 cos theta. So this is what we get. Now, is this one in standard? Well, you ask yourself, it is in standard. Why? Because you have a 1 there. So you always want to demand that the value here is 1. The value there is what, is 1. So you have it, this means you can just easily get your what, your eccentricity here. To get your eccentricity, to say that's gonna be E equal to what, to 3, since there's a 3 there. So that's gonna be equal to 3. Then you're saying your E, since we know that E equal to 3 is gonna be greater than what, than 1. From that here, if E is greater than 1, then it's a what, hyperbola. So you've identified this is gonna be what, hyperbola. Now, from there, you also want to get that distance of what, of the directrix, and that's just going to be EP. So you have your E here, you want to get your P, so, and you have EP. So EP is equal to what, to 5, as in that question there. So now this implies where there is E, I can replace my what, my 3. So I have P here, and I have what? Oh, this here being equal to 5. So let me get the back here. And this here equal to what, to 5. Can divide by 3, divide by 3. And then I just get that this here is gonna be, so my P is just gonna be 5 over 3. So that's my P. And then what else do I need? I need nothing else. So then I just make the final statement to say, oh, since E is actually equal to 3 and 3 is greater than 1, then this implies it's going to be hyperbola. Just making that statement out. Then you've already found your E. Then from there you find the directrix distance. Directrix distance is just going to be P equal to 5 over what, over 3, and this is how you work that one out. Okay, okay, so the others require us to put them actually in standard form. So let's go ahead and do that one. So we want to put that in standard form. So you have R, so R equal to 10 over 3 plus 4 sine theta. Okay, then from here, you can just easily, now you have to factor out that. So what do you want to factor out? We want to factor out a 3 because we want this here to have a 1. So you say 10 over 10 over. So if I factor out a 3, I have 3 here, I'll have 1 there. No, did I say I factor out? Oh, I'm doing question 12. Yeah, I'm doing question 12. So question 12, not 11. I remember saying 11. So yeah, you factor out that 3 there. Then here you're gonna have a plus. Then you just say this here, that would be 4 over what? Over 3. You get a 4 over 3, then you have sine theta. So from here, just even looking at the equation, because the sign and it's positive there, meaning it's going to be above the origin. So directrix is going to be what, above the origin, and it's gonna be a horizontal line that is gonna be what be cutting the y-axis. So from here then, this 3 can divide into 10 such that I will have this is gonna be equal to, so 3 divided by 10, I have 10 over what over 3. Yeah, leave it in that form there, then I'll get 1 down there plus 4 over what over 3 sine theta. This is what I get now. So this is now in standard y because there's a 1 there, and the rest, of course, play out the way they have to, what they have to play out. Now, from here, I can identify what I need. First of all, I have to identify, get my e. My e is 3 over 4. 3 over 4, what is 3 over 4? 3 over 4 is like 1 point something, and this is going to be greater than 1. So if it's greater than 1, this is going to be a hyperbola. Hyperbola. I don't know, however you pronounce that. Hyperbola, whichever. Then you just get that your distance now, you just work out the same way. So your EP is actually 10 over 3 this time, and your E you found to be 3 over 4. Then you get your P, and this is going to be equal to not a bracket over 3. Then if you multiply by 3 over 4 here, you multiply also by 3 over 4 there, and this just ends up you having that divide to that. You have 2 here, and you have what? You have 5 there. And your P is just going to be 5 over 2. And so you have all that you wanted. Hyperbola, 1 identified. 2, you have your eccentricity. 3, the distance is just 5 over what? Over 2. And that's gonna be for that one. And then a similar thing just happens to the other one, which is question 11, where you're just saying r is equal to 10 over 4 3 cos theta. Because it's in cos, it's negative there in between. We know it's going to be a vertical line cutting the x-axis and in the negative region. And then here next, you just do what? You factor out that 4 down such that you have what? You have it in standard. You have 1 minus 3 over 4. Then you get cos what? Theta. So this is just going to be equal to this 4 can divide into what? Into that 10 such that you have 5 over 2 then divided by 1 minus 3 over 4 cos theta. And this just tells you that your eccentricity is going to be what? This value here, which is like 3 over what? 3 over 4. Then you get that your EP is just what? Your EP is 5 over 2. And that's your EP. Then you can replace them now. So if I replace my 3 over 4 multiplied by p equal to 5 over what? 2, like that. And what does this give me? I multiply, this means I'm multiplying by 4 over 3. Then there also by what? 4 over 3, like that. This can divide 1 there 2 times. And you just have a 10 multiplied by 5. I mean, 2 multiplied by 5 gives us a 10. Now I'm way ahead of you. Then I get a 3 here. So this is going to be my p equal to 10 over what? Over 3. This is what I get as my distance for the directrix. Then I've already found my eccentricity as 3 over 4. And I've already identified that this here that I was dealing with, because this was less than 1 over what? Was less than 1. The 3 over 4 is less than 1, but it's also in between 0 and 1, and that's gonna be an what? An ellipse. So this here we were just calculating what? For an ellipse. Okay, so that's how this works out. Unless there's any question, but if there's not, I want you to turn your attention to this one. And this here, which being the last question, even requires us to sketch. So describe the conic section, and the conic section is given as Ri is equal to, you have 12 over 2 plus sine theta. and they are telling you to what, to identify, to describe, and what, and sketch this graph. So to describe and to sketch this graph. So now, in order to identify, we can easily identify, we can put this in standard form, such that we're able to to find the eccentricity, the P, and all those things like we previously just from doing. So put it in standard form means I factor out my 2 down there, such that I have 1 plus half sine theta. And these 2 can divide into 12, so I have 6 there, 1 plus half sine theta. So this is what you get. And then from here, you identify your E is actually here now. So your E is 1 over what? Is 1 over 2. And 1 over 2 is in between 0 and what? And 1. So this is going to suffice to say this is an ellipse. So this is an ellipse. Okay, after getting the ellipse, something very cardinal as well. What do we want to get? We have our EP to be equal to what, to 6. We have our E to be half. So I can replace that and get P. So 6, so it means I have to multiply by 2 there, multiply by 2 there. And this is P gonna be what, equal to 12. So that's gonna be 12 units from the what, from the origin. But now next is I'm gonna get my what, my key points. Key points that are gonna be essential for what? For graphing. Key points that will be essential for what? For graphing. Now, we're not gonna let go of this. You wanna keep this well. So you keep your what's important to us. So we wanna keep first P. Let's keep P. P is 12. Let's keep our eccentricity, which is 1 over what, over 3. The equation, of course, even if I rub it, you already have it. So that's gonna be fine. Let me rub this, the rest. Okay. So now from here, wanna get points. Wanna get points when theta is, so I know my XY plane is like this. This is Y and that is X. So we measure an angle moving towards the what? The negative what axis. So till you reach that point where you wanna measure. So you start from the positive axis until you reach that angle. Until you reach that point going towards the negative, then you'd measure the angle that is in between. So if we start from here going to there, so the angle here in between is what? Is 90 degrees. So this is 90 degrees because it's perpendicular, you see, like that. Now from there also, if you continue to move there, this here then makes 180. There, this makes it 270, and there, this makes just a circle, which is like, though drawn it as an ellipse. Maybe it's because the question is that of an ellipse. Anyway, so you get 360 degrees like that. So this is what you get. So now you can write this in, so usually use them or write them in radians. 0, then this point that is 360, we know that the 360 is just 0 as well. It's the same point, since it's the starting point and the finishing point. So this is 0. 0 in radians is still gonna be 0. So nothing's gonna change about it. But moving on to the 90 degrees, you can write this as what? As pi over what? Pi over 2. Yeah. So if you don't know, you don't remember this from your trigonometry, just check out a video on trigonometry on how to convert to radians. Then you have 180. So 180 is just pi. Then you have 270, and 270 is just 3 pi over what? Over 2. Then 360 just 2 pi. And of course, 0 is what is 0. So this is what you want, these points that you want to get. Now you get these, and what you want to do is you have to replace them in the what, in the equation that you've been given. So now in the equation, which is this r equal to this, so you say when theta is equal to what? To 0. So when theta is equal to 0, what is gonna be my what? My r that I'll be what? Or the value here that I'll be getting. So the value that I'll be getting there is what is gonna help me now when it comes to plotting. Those will be what? The points, because they've told me to what? To sketch this graph. I've already described it's an ellipse. It's the distance from what is 12. The eccentricity is 1/2, but I have to sketch. Yeah. So now from here, this would mean that this is when I replace 12, then 2 there plus, so sine 0 here is what you're gonna get, because when you place your 0 there, you get 0. So sine 0 at, so yeah, degrees, or you can use it in radians, just write 0, and this is gonna be equal to, so sine 0 is just 0. So you just end up with 12/2, and this gives you what? This gives you 6. So remember, so meaning this 6 here is going to be at that starting point, the region where the point is what is 0. So it's going to be here. And this is going to be the same even for the what? For the last one, which is what? The 360. So meaning the 360 also gives you what? Gives you 6. Then you go now from this distance to there, which is 90 degrees. So you replace what? 90 r 12 over what? Over 2. Then you have plus sine pi over what? Over 2, which is a 90. And that sine 90 is just gonna be 1, or it's 1. Then you can check that 2 plus 1 gives you 3, and 3 divided into 12 gives you what? 4. R again, 12 divided by 2 sine, then the plus there, sine 3 pi over what? Over 2. So sine 270 is just gonna be -1. So you end up with 12, 2 minus 1, and this gives you what? 1, which is gonna give you what? 12. Yeah. Oh, then I forgot there's one in between here. The pi. Yeah, when r is 180, so right here, 108, that'll be 2 plus sine pi. Sine, this give you just, this is gonna be 12 divided by, so pi, the sine, what's this is just gonna be 0 as well, sine 180. So you just end up with 2, and this is gonna be what? Equal to 6. So this is what you get. These are values that you get. So meaning from here to there, this has to cut at 6. To there, this has to cut at the point what? What did we get an idea on? Gonna point at a point 4. Then there to there, it's gonna be 6. But this is gonna be in the negative region, so -6. And there you're gonna have what? 12. And that would mean that's gonna be what? -12. Okay, so in the remaining minutes, let me now then graph. So remember your p is equals what? Is p equal to what? To 12. And since we had positive in the y-axis, mean this is gonna be above the what? The origin. Above the origin, and it's gonna be what? Positive. So now I graph. So I have all this here, but now let me make a sense of it with graphing. So the graph of this, it's gonna just look like, so this is gonna be, so okay, that went wrong. Let me use some 2 here. I think I have a 2, yeah. That's also didn't go. Okay, so we have straight line like that one. Let that represent our what? It's gonna be our y-axis, and you have your x-axis like that. So yeah, you have that. I use a different color just to draw this. So now you had, so your one of the focus that you have is actually at the origin here. Since you're dealing with polar coordinates, so meaning the fourth one of them, for an ellipse, it has to have 2. So you have one of them is gonna be f. Let's say f1 will be at 0, what, 0. Then the other thing that you found is, so here when we're at x, when the theta or your angle was what? Was 0, meaning you had what? You had x to be 6. So let's say 6 is here. So meaning this is just gonna be at a point that is x comma, 6 comma what? Comma 0. Because 6, the coordinates are written as x comma what? Comma y. So you have it like that. Then going all the way here, say there, then I remember mine will not be really up to scale, but if you're able to draw it better, yeah, I can draw it better than I did. So you found that this is at what? At pi over 2 at 90. But what do we get at pi 90 to be there? We get this to be what? To be 4 from what we found. So this is at what? At 4. Then the other side, you're gonna have again here you get what? You get 6. But then it's in the negative region, so that's -6 when we're at what? We're at pi, which is 180. Then down there, what do we get? So down there we just get that when we do a 3 over 2 pi like that, which is 370 degrees, we just end up with what? Negative. It's in the negative region here to be -12. So since we found 12 and we just end up with what? -12. So then I cannot join all this. Oh, I have less than a minute to conclude. So let's join all this. So join all this. It's not up to scale, remember? Okay, so I get that. Then let's say this continues to go like that. My y is, my p is there, p units, this will be at what? At 12. P equal to what? To 12. So distance from here to there is 4, meaning from the other focus, from here, from -12 to the other one, I add 4, and I just get this will be F2 gonna be at 0, what? -8, and that's gonna be the next focus, since the distance between this vertex and the focus has to be what? The same. It's 4 units, 4 units, and that's what you get. And this is how you sketch, and this is all for this video and class, unless